Everybody. So we're going to start by passing back these tests and talking a little bit about, the tests and what happened here. Feel like I kind of let you down a little bit on this, is that scores were not very good. Class averages in the 50s. So we're going to spend a little bit of time today kind of talking about what's going on and kind of what we're going to do to kind of help fix that. But I'm going to pass back these tests first and let you look at it. No curve was applied to this because I have something we're going to do to fix the grade instead of just putting a curve on it and moving on. Because there's at least one topic here that we need to do better on as a group. So I'll do a little bit more instruction and some example and give you guys some stuff to work on, and we'll use that. So I have some old papers as well as the tests, and I'm just going to be passing these guys back. You guys all got so quiet. Like everybody's very scared. I'm not trying to scare everybody. I'm just trying to be honest about there. I knew how to do that. I'm just I knew how to do that. Yeah, I did that. It's not how it is if you want to do something. So wait, this is not. Wait, it's this. You know it's really guys. How many times I tried to write it? No one asked me. Wait, I don't want to talk to you. Okay, wait. You wouldn't let me be your partner. No. Stop. Bad. Oh gosh. Oh my gosh, I thought it was crap. Wait, do you like average? It's because you're low. Yeah, there's one. I'm proud of myself. Yeah, I don't it's not bad. All right, here. No, it's about half. Oh, it's purple. Wait, is the front pretty close to half overall score? Okay. What did you get? So the piece that I want to focus on would be like just the integral problems, like the algebraic integral problems that would have been on the part 2. This is the area that really I felt like we had the most issues and the most problems. So I want to talk a little bit about what was going on with those problems and kind of how to recognize what to do and do some examples, and then we're going to do some additional practice with those. Okay? Everybody good? All right. So there were basically 4 types of problems on those integral problems. There were ones that could be done just using your anti-differentiation rules. There are ones that required a little bit of algebra to get it to a place where you could use your anti-differentiation rules. There was U sub, and then there was that nasty absolute value problem that like 3 people did it right. So I want to talk about, like, or do an example of kind of each one of those 4 types, and kind of how to, what I'm looking at, what I'm recognizing, and how to kind of talk through what I'm, in my head, what I'm thinking through while we do these, okay? So I'm going to do 4 example problems and kind of talk through these. I'm just going to kind of make them up as we go. Right, all right? Okay. Okay. So this is an example of a problem that can be done entirely with just our anti-differentiation rules. So when I look at this, the first thing I recognize is that I see addition and subtraction going on, right? You guys see all the addition and subtraction symbols? That's going to allow me to distribute the integral to each piece and turn this in, or change this from one problem to like 3 separate problems. Or 4 separate problems. Everybody okay there? So if I look at the first piece, 2 to the x, I have an antiderivative rule for this. What is the antiderivative of a to the x? So it should be everybody saying this all at once with no hesitation. We did a quiz on this. We should have memorized all these. Good. A to the x over the natural log of a. So the a in this case is 2. Okay, the next piece, I need the antiderivative of sine x, which is negative cosine x. And then I have the square root of x. Do I have an antiderivative rule for square root of x? Yeah, if I think about it as x to the 1/2, I sure as heck do, right? What is it then? Good. And then I have 1 over 1 plus x squared, which is not tan x, tan inverse x. Yeah. And then I need a plus c, right? So again, the first thing I'm looking for is, can I just distribute this integral across to each term? And then, can any of these terms just be handled by like one simple antiderivative rule? And if they can, like that's all I need and I'm basically done. Right? I might have to apply multiple rules. It's okay. It's fairly easy once I've recognized that, oh, that's just one of the rules. Oh, that's one of the rules. That's why we memorize them. Because we need to be able to see those instantaneously. Everybody's okay? Another situation that we had on here were problems that we had to use some algebra on first to get it to a place where we could apply an anti-differentiation or antiderivative rule. Oops. Okay. First thing I'm going to recognize is that the addition, which means that I can create this into two separate integrals, right? Good. So Vinny says that, I'm sorry, Anthony says we need to do this. Is that what you mean? Or did you mean? Yeah, like this. Wonderful. Everybody's okay with what we did? Now we can reduce these fractions, right? We'll come back to that in a second. Everybody okay with what we did? If it's too fast or you're not sure, speak up. This is me reteaching a topic that we didn't do real well on, so I want to make sure that as I'm talking through this, you're following what I'm doing. Don't just like sit there passively and let it wash over you. Like, engage. Hang on as best you can. I'll pause here. If it's going too fast, let me know. Or if I need to re-explain something or you're not sure why I did something, again, let me know. Ask questions. It's okay. Doing okay? Let's look at the other piece here. We have tan squared times cosecant squared. It's not an antiderivative formula, right? What do I do with this? Yeah, so I'm going to use some trig rules, right? Tan squared is sine squared over cosine squared. Cosecant is 1 over sine squared. So this is 1 over cosine squared, which is secant squared. Okay? Now, we've got this into a form where I can just apply my antiderivative rules. What's the antiderivative of x to negative 3/2? -2. Pretty good. Okay. And the next one should be? Right? Everybody good still? Antiderivative of secant squared. Tangent. And then I still need a secant. And again, you could clean that up a little bit by negative and negative and making a plus or whatever, but like, whoop-de-doo. Everybody okay? Now, there is no way to have attacked this without doing what we did there. Okay? U sub isn't going to get you there. I saw some very bad things from some of us as an aside. So I saw a lot of I saw a lot of people doing this, where the integral of a product is the product of the integrals. Never true, very bad. Cannot do that ever. And I saw a lot of people do this, that the integral of a quotient is just the quotient of integrals. Again, wrong, always wrong, very wrong. Cannot ever do this, okay? Okay? So, this level of mistake is a 0-pointer. Even if you did like the correct antiderivatives after you did that, that as a starting point is a 0 for me. Right? That's like saying that I can distribute exponents or something like this. Fundamentally can't manipulate an integral like that. We've never done anything that resembled that. That's a no all the time. Okay? Just like for a derivative, if I have a product of two functions, I can't just take the derivative of each factor. I have to use the product rule. There's a special rule that I need to apply to take the derivative of a product. If I have the integral of a product, there are special rules that I would need to apply to deal with that if it's not one of my basic antiderivative rules. The only tool we've seen to handle the derivative of a product, unless we can combine those two products together, like via multiplication, like algebraic rules, is u substitution, or one of our basic antiderivative formulas like cosecant times cotangent is the antiderivative is just cosecant. Right? That's it. That's all you got. We'll talk about integration by parts in the future. That's a tool that will also be able to deal with some of these product situations. If I take the derivative of a quotient, can I just take the derivative of the top and the derivative of the bottom? No, I need to have a special rule that I need to apply to do that. There is no special rule for integration of a quotient. We talked about a couple of the techniques you could use, depending on what your quotient looked like, but in general, there is no good workaround for the integral of quotient. Like it's a tough problem. Okay? These two things, I don't want to see anybody doing again. Okay? Maybe we weren't clear enough about that, but I'm going to be real clear right now. Okay? Those are like level of mistake I don't want to see happen again. Okay? It's your first time doing this. I can live with, like, it's fine, but we're talking about it now, and I really emphasize, cannot do those. Okay? Okay. All right. The next type of problem is a u substitution. What is my cue that I'm looking for to know that I can do it, or that I should be looking at a u substitution? Well, a composition, right? You said chain rule, but like a composition of two functions is typically my indicator. And I say typically because it doesn't always indicate, it's not always going to be that, but that's usually a good indicator. Actually, I'm going to do this. Something like that. What's the first thing that I notice? Subtraction. What am I going to do with that? Distribute the integral, right? So again, we can distribute integrals across addition and subtraction. That's totally fine. Not multiplication and division. If I look at the first integral, what do I see there? I see a composition, right? The outer function is sine x, and the inner function is 2x. That's my cue that's a typical u substitution presentation. Now there can be u substitutions that do not present like this, but this is a very classical presentation. So what do I choose for my u typically? The inner function. So in this case, we'd choose u to be 2x. Okay? My next step would be to differentiate with respect to x. And now, if I look at my problem, I'm going to be subbing the u into this. So my leftover is dx. That's it for my leftovers. So I need to get dx by itself in this equation. So I'll multiply both sides by dx and then divide by 2. So when I make that substitution, I'm going to have sine of u times du over 2. Everybody satisfied with what I did there? Okay. If I look at my second integral, what do you notice? See a composition. What is my outer function? E to the x. So it's my inner function. X squared minus 5. I also have that times x there. That's going to be part of my leftovers. I don't know how it's going to get covered in right yet, but like, I see the composition. I'm going to at least start by trying the most reasonable thing, which would be picking my u to be the inside part of my composition. I then differentiate with respect to x. So when I do my u sub, my u is going into that function. So my leftovers are x dx. Can I make an x dx here? Yeah, right? Because I have the x and I have the dx. So again, I'll divide both sides by 2 and multiply by dx. So this stuff, the x dx, is just going to be replaced by du over 2. Everybody feel okay? So I'll pull the 1/2 out front. The antiderivative of sine u is negative cosine u. The antiderivative of e to the u is e to the u. And we have our plus c. And am I done? No, what do I still need to do? Put my u's back in. No.
Christian, where did the e to the 4 come from?
That's a u. It's just bad penmanship on my part.
Where did the x go from x to u?
So this is equal to du over 2.
Okay.
So I took the x dx and I replaced it with the du over 2. Does that feel okay?
Yeah.
So again, I'm going to look at, this is where my u's going into. These guys are my leftovers. And want to see, can I make those leftovers out of that derivative? And that's what I try to do algebraically every time. Is that?
Yeah.
Okay. Again, it's the finer points here, right? And that's done at this point, right? We just have to, we put the function back in or the u's back in and we're done. So far so good? Let's talk about an absolute value problem. So I'm going to talk about it abstractly first, and then we'll peel down to a specific example. So if I'm just taking the integral of an absolute value function, it must be a definite integral for us to do. If it's an indefinite integral, I have no idea what to do with that. As your teacher, I would have no clue what to do with this. It has to be a definite integral. It's the only thing you'd see if it's an absolute value in it. Okay? All right. So what does an absolute value mean? What does the absolute value do to a function? Makes it positive only when it wasn't positive, right? So like our piecewise definition, is just going to equal f of x whenever, for all the x's where f of x is positive, right? And then, oh boy, and that would be negative f of x for all x where f of x is negative, right? How am I going to find out what values of x the function f of x is positive versus negative? Yeah. So I'm going to take f of x and set it equal to 0, right? So let's say, for example, f of c is equal to 0, and c is in between the values of a and b. So what that means then, and I guess then furthermore, and let's say that f of x is less than 0 on the interval from a to c. Let's say that was the negative part. So what we can say then is I can change this absolute value function into two integrals. So I can do the integral of negative f of x dx from a to c plus the integral from c to b of positive f of x. So for me to ditch that absolute value sign, I need to break it into multiple integrals where I put a negative sign in front of the part where the function is negative and a plus sign in front of the part where the function is positive. And then I just evaluate it as normal. Everybody okay? Let's do an example, yeah? So let's say it's the integral from negative 2 to 3, absolute value of x squared minus 1 dx. So first thing I notice here is the absolute value. So what I need to do is break that function, x squared minus 1, up into the parts where it's less than 0 and greater than 0. So we'll start by setting it equal to 0 and find out where it transitions from positive to negative. What are the solutions to this? Negative 1 and positive 1. Now, basically what I'll do then is I'll make like a sign diagram where I can pick like some test values here, right? But I don't really need this. You should be able to look at the function x squared minus 1 and tell me where that function is positive and negative just because you know what the graph looks like, right? Should be that. What's the graph of x squared minus 1 look like? Parabola. Which way does it open? Up. Where is it below the x-axis? In between the zeros, right? All of us should be able to do that with no calculator, just from what we know from Algebra 2 and pre-calculus about what a quadratic looks like. All right. So from negative 2 to negative 1, my function is positive. From negative 1 to 1, my function is negative. And from 1 to 3, my function is positive again. Okay? Okay, notice by breaking it up that way, it allows me to dump the absolute value symbol, which I have no antiderivative formula for. This is why we need it to be a definite integral for us to handle the absolute value function. Without that, there's no way to indefinite integral to break it apart.
That's good. Can I call Caroline right now?
Yes.
You're not in trouble. Okay. She'll be right back.
Because you're always in trouble.
Nah.
Is everybody so far so good? Okay. Now let's do the antiderivatives. So then what's the antiderivative of x squared? X cubed over 3. And the antiderivative of 1? And it's the same antiderivative for each integral. So that's rather nice. Everybody feel okay here? Okay, now we're just going to be evaluating. So for my first piece, I'm doing top minus bottom. Is everybody okay with how I plugged everything in? Okay, so I'm going to have negative 1/3 plus 1 minus negative 8/3 plus 2. And then I have a minus, probably just send that through, makes it easier. So I have a minus 1/3 plus 1 plus negative 1/3 plus 1 plus, that's going to be 9 minus 3 minus 1/3 minus 1. Is everybody okay with the arithmetic I'm arithmeticking? So that's going to be negative 1/3 plus 1 plus 8/3 minus 2 minus 1/3 plus 1 minus 1/3 plus 1 plus 9 minus 3 minus 1/3 plus 1. Everybody's okay with me arithmeticking here? Now combine some like terms. So I have negative 1/3, that's positive 7/3, positive 6/3, positive 5/3, positive 4/3. And then plus 1 minus 2 plus 0 plus 1 plus 10 plus 7 plus 8. End up with 28 over 3. Yeah. Okay, Anthony?
Instead of subtracting the one that's greater, could you solve it into 3 parts and then make that part positive?
Yeah. Yeah, I think so. You're asking to like distribute it here? Yeah, you could do that. Right, that's what you asked? Yeah. So what Anthony says is, could I do this before substitution just to cut down my negatives? For sure. Okay. So, for points back, we're going to give you guys an assignment. It has 8 integrals like these ones we've just kind of done together. They all fall into like one of these 4, or they just involve these 4 techniques that we've talked about. Each correct response is worth 4% on your test grade. So if there's 8 problems, how much total percentage back can you earn? 32%, right? Now, max grade is capped at 100. That means anybody getting 130% on a test. But that makes a big chunk of improvement on where you're at. So if you were in the 60s, you can end up with a 90, you know. If you're in the 50s, you end up with an 80. Recovers a lot, makes up for a lot of ills here. Okay? You're going to do this assignment with a partner. You're going to have groups of 2. I guess today is an odd class, right? Odd number of people. Let's do this to make it fair. There's 15 of us in here, right? Okay. Oh, that's weird. It is the random integer that came out was 15. So I guess we'll start here. And we just would count off. Sam, you've been the last person. You can have the group of 3. Everyone else will be in a group of 2, unless you're with Sam. We'll have 3 people. Once you've found your group, you'll come collect your assignment. There are 8 distinct sets here, so each group is going to have a different set of 8 problems. These problems will be done with your partner in class. If you need more time than it has today, you can come back with your partner and work on them during a CT. But the problems and your work stay in this room. But you can have as much time outside of this class if you want. It just has to be done during CT. So you take 1 CT, 2 CTs, 3 CTs, I don't care. And keep coming back until you're satisfied. Does everybody, does it sound fair? Yes, Sarah.
Can we get help from you?
You can ask me questions. I'll be happy to tell you if things are right or wrong, or like you're not sure what to do. You can help talk through what I would see. I might not tell you what to do, but I will help you and give you some shoves in the right direction. So depending on what the problem is and how difficult it is, the level of help I'm willing to provide may vary. Does that sound fair to everybody? Are we happy with this solution? I think that puts the class average in a respectable place. Mid-80s, I don't think anybody should be complaining too much about. In fact, that's probably a better curve than most of the time we get. And hopefully after spending some time really working on these, we clean up this particular set of skills so that you are a problem for international terrorists. That's a taken joke. No. It's a movie from 10 years ago that probably you've never seen. So Liam Neeson's like an special forces guy, and his daughter's kidnapped, and the kidnappers call him on the phone, and he tells them that he's a problem for them because he has a particular set of skills. And I was talking about our particular set of skills, and I felt like it was a taken joke. Yeah. All right, so once you find your partner or partners, in the case of Sam, come up and see me and I'll give you your problems.
Wait, so we're picking?
Yes. Since potentially you have to figure out a time to come back during a CT, I don't want to assign you somebody that you don't know or see, or I'll let you choose, because if you have to come back, it'd be helpful to have somebody you're communicate with. Who's your partner?
Yeah.
Yeah, so just for a little bit, one side. On a separate sheet of paper, please.
Yeah, you did.
Yeah. I didn't make a third set for you. So you just like
Where's the work?
separate sheet.
For some breath.
Well, if you wanted to do that, I would have given her a 3-person. Who doesn't have a partner? Okay, I'll just see what we have.
Just like get your pencil, get your calculator.
Why don't you say it's only right there? And you make some suggestions. You know? It sounded more. Welcome.
Oh, these are warm.
I've been holding them for a minute.
Oh, I don't think you have them.
No, I printed them yesterday, so I didn't imagine it's still warm. So again, so you guys, I just want to do a little bit of clarification here before anybody gets too deep into this. Your work should be done on a separate sheet of paper. 1 copy per group is fine. I encourage you both to be writing, so you have a chance to work through things and make sure that, yes, I agree, that's what I did there and all of that. I think that's really productive. Neatness and clarity count, right? Like this should represent like the best work possible from you. So like good organization, good penmanship, should make it easy to read, like go slow, be careful. If you have questions on stuff, feel free to ask. I'd be happy to, take a look at what you're doing and give you feedback. And
Wait.